All right, so before we get started, we're going to actually go over a brief agenda, and we're going to talk about a few things today. First, we're going to talk about what is Puppet and automating your infrastructure for CI/CD and why you should use Puppet. Can I get a show of hands of how many folks here are using Puppet currently, have an understanding of Puppet?
Ooh.
Awesome. This is what I suspected, so very good. And then we'll be moving along to Docker.
So I would be curious, how many people are using Puppet in Docker in production today? Excellent. How many people are new to Docker? This is my group. So we are going to be talking about some foundations for Docker, and then we're going to go into build, ship, and run, which is moving from development into production with Docker using Puppet.
Awesome. Let's go ahead and get started. So we're going to get started with what we're calling the Puppet Show, and we're going to talk briefly about automation. Since everyone in this room has some experience with Puppet, we're not going to spend too much time on this section. But what do we use Puppet for, and why is it valuable to us? And so in the world of Puppet, we say that we help to automate for speed, reliability, and for security. And we do this in 4 ways. One, by creating a unifying language that allows for you to even talk to your environment. This is known as a Puppet code. It defines the state with that unified language right there in your environment, which allows for you to gain situational awareness. By using and leveraging the same kind of code to manage everything, you're able to understand what's happening, where it's happening, and why it's happening. And this allows for you to then be able to orchestrate change and maintain any of the desired state parameters that you want in your environment, which of course leads you to having the ability to ensure security and compliance across your environment. We do this in a very familiar architecture. So this is a diagram of Puppet architecture. It's a client-server architecture here that we have, with the Puppet master serving as the server, and then our agents being the clients. The agents can be any OS, they can also be network devices, and they can come from any platform, whether it's a cloud platform or a containerized environment. And how does Puppet work? So this is a diagram of a Puppet workflow. And what we have here is the definition of that desired state. So this is a small snippet of Puppet code, which we have here. We're declaring a resource, being a service in this case, NTPD, and we're telling Puppet how we want that service to be configured. We want it enabled, we want it running, and we want it looking at this ntp.dconf file. So we have that here. And we'll take that code and we will then be able to do a few things: simulate and enforce that configuration. So in the simulation mode, known as no-op, you're able to apply changes to see what would happen without actually enforcing those changes. And so that's really neat because you're able to receive reporting on this as well. And then you're able to then move into the enforcement of that configuration, and you're able to maintain that configuration across the life cycle of that resource or that environment, whatever your needs might be. Once again, the reporting piece is really pivotal here because Puppet is reporting on everything it's doing. It's allowing for you to see where these changes are occurring, and it's allowing for you to continue that long-term maintenance of those resources as you need, as well as being able to differentiate between the kinds of changes that are occurring. Do you have intentional or do you have corrective changes? This is a really cool functionality of Puppet because it helps you identify if there's drift occurring or if people are using a Puppet prescribed workflow in order to create or maintain any configurations you want. This is really vital and part of that integration with Docker because it gives you the insight that Puppet has in a new way with containers. And we're going to talk about exactly what that interaction looks like here in a second. But first, we're going to have Tricia talk a little bit about Docker. Actually, I skipped a little bit ahead, my bad. We're going to actually talk about Puppet Enterprise and what the difference is here between open source and enterprise. What we're going to be showing you today is available to all users of Puppet, whether you're using open source or whether you're using enterprise. The key difference is going to be that enterprise has the user interface that we're going to be leveraging in our Docker example after doing some stuff on the command line. And also that Enterprise has role-based access control and some of the visualizations and reporting that I've been talking about a little bit earlier. So we're going to be using that as well to see how we can introspect our environment after we've applied a change or brought up a container in order to see what's going on. And then there's, of course, a few key modules that are enterprise only, and we also have some support options that are enterprise only. All right.
Okay, so we'll start off with the Docker architecture. The way this looks is you have a node in Puppet, or we'll call it a Docker host, and there is a Docker daemon that then it's just a service on the host itself that manages the images and how to run them. So we have a Docker registry, which is, think of it like your Git repo for Docker images, that you can pull down this image. An image is essentially a way of isolating and bundling up your application and how you're going to want it to run. And then the container is when you actually instantiate that image. And you can manage that all through the Docker client, essentially the command line of build, pull, and run, or just way of interacting with the Docker engine. So a container, and we just touched on that a bit, but it is a way of bundling up your application environment so that if you need to run it somewhere else, you won't have to go ahead and install Python or pip or whatever else you need. It's already built into that container, so all of that dependencies and libraries in your application code is just where you can run it anywhere. And it's a way of isolating applications from each other, but still running them on the same host. And containers share the kernel. So this is part of the beauty of it being lightweight and starting out quickly. And it is supported for pretty much all the major versions of Linux, as well as we now support Windows Server 2016. Quite often, we hear that containers are like VMs, right? It's just another way of understanding what they do and how they work. But they have similarities in the sense that they isolate applications, and they're a way of being able to move them and scale them across your infrastructure, but that's about it. There are significant differences and benefits for using either, or a combination. So we'll start with the fact that containers, and we'll use a bit of an analogy here, but containers are like apartments, right? They're small places where you'd live. It is not essentially the footprint of a home. They share resources, so like plumbing and electrical for that apartment, right? And so that's where containers are similar to apartments, because they are that isolated namespace, but they also share an infrastructure, giving them that ability, because they're sharing the kernel of the host, it gives them that ability to go ahead and boot quickly. And also they're sharing the operating system. And they're a smaller footprint. So the Alpine image in a Docker container is about 5.5 megs. Whereas when we look at a VM, think of it as a house, right? It has its own foundation. It has its own plumbing. So again, it has its own isolated resources in a VM where you designate CPU and memory and disk, and then install an OS on top within that VM. So it has that full OS and kernel. Therefore, it takes it a little bit longer to boot, as well as has a larger footprint. You know, the smallest VM I've ever worked with is at least still a couple hundred megs, right? So containers are going to be quicker to start up, as well as a smaller footprint, right? Instead of having 100 VMs with the exact same operating system installed within it. Whereas a VM, you still get to leverage that hypervisor, right? And being able to like vMotion and move them around easily, and using that workload or that workflow process. However, that doesn't mean they can't coexist. So on the left-hand side, we see a bare metal Docker engine environment. So you have your physical server, your operating system, and your Docker engine installed, and then your individual containers running, right? So you have all your application and library requirements. But then over to the right, you can do the exact same thing within a hypervisor. So you have, say, your non-prod environment where you have app 4 and 5, and then your production system where it has app 6, again, they have their own operating system and Docker engine on it, so you might have requirements where you have to have different environments. And then you can still run VMs, right? So you can still have your existing infrastructure running. We would recommend using the Docker engine on bare metal when you're looking at performance requirements. So a bit of vocabulary here. Docker image is that way of encapsulating your application in libraries and how you're going to execute the application. And then a container is a way of running it, right? So it's instantiating that image. The Docker engine is what actually manages, makes sure that that image is available on that host, as well as what parameters you want to pass and maybe port forwarding for that container. And then finally, the Docker registry services, like our Docker Hub, is that where you store your images. Now, we have the GitHub, the Docker Hub, which is like a Git repo for images. But you can also, and probably your companies are running trusted registries, where you have your own private images hosted. And I have technical difficulties.
Let's see. Let's go. The next slide is.
Oh, there we go. So there are 2 versions of Docker out there. There's a Docker Community Edition, or CE. This is what you would probably download and install on your desktop, and giving you just a quick way to get going as a developer or a small company. And then we have the Enterprise Edition. This is very similar to Puppet Enterprise, where you're going to have additional things like trusted registries and certifications, as well as support and services. What we're going to be going over today, it's Docker CE or Docker Enterprise. And a common term in Docker is build, ship, run. Again, that's how you go from development into production. So on the left-hand side, you have build, where you have probably Docker CE with your developers. They're building that image, and they're going to go ahead and ship it and upload it to a registry. And then that gives you the ability to run it anywhere. You can run it on another desktop. You can run it within your infrastructure or out in the cloud environments. This is what a Docker file looks like. Now, we are going to be leveraging Puppet manifests and using a module called image build to be able to build a Docker image without having to know any Docker file syntax. But this should look really similar to writing a shell script, right? So we're starting it off saying we're going to use the Alpine image. And then we're installing Python and pip, upgrading, and then moving in my requirements. So that requirements is essentially saying I need to install Flask, so those dependencies, and finally copying in the application, opening up some network, and then how I'm going to start this, right? It's just a Python start. So that's how simple Docker files are. But if you are starting off, I'd recommend using what you already have in your manifest.
So let's talk about what we're actually going to be using today to give you our example that we have later on. We're going to be using a few modules from the Forge. We're using the Docker Platform module as well as the image build module. And what the Docker Platform module is doing is it's installing, configuring, and managing your Docker daemon and Docker containers. So it's a part of that previous diagram that Tricia showed us. It's the beginning part about building and shipping. And then the image build one is going to help us actually build those images from Puppet code that we currently have without having to create or run Docker files. So being able to leverage your current Puppet infrastructure in order to get yourself containerized. And then we're also using PuppetConf repo that we created that Tricia did a lot of really wonderful work on. And what that allows for you to do is it allows for you to just execute these examples that we're going to be showing you today about running an Nginx module and then also running a separate image coming from the Docker Hub. So we're going to give you 2 different kinds of examples that leverage these modules. And then also there was a release yesterday of a new and improved Docker module. We're not leveraging all of the capability of that module because it was released yesterday, but it lets you do a few additional things like Docker Stack and some other key features of Docker. So I encourage everyone to go check that out and see what that release holds.
Yeah, we do have a couple of more advanced sessions later tomorrow, and we'll tell you what those are at the end of our talk. So this is just an example of what we're going to be looking at, and I just want to preface that. All right, so this is a manifest file where we're looking at starting an Nginx container. And the first thing you're going to see is that Docker, that include Docker. What that does from that module is whichever node that this is being executed on, if a Docker engine is not already installed, it's going to go ahead and install it for you. So it ensures that Docker is available, so then it can go ahead and do a Docker run. And then in the Docker run command or section of that is it's saying that if this image doesn't exist, go ahead and download it. You can pass in, you can also create a Docker registry section where you then, if you have your own private registry, you can pass in your login and parameters. And of course, you can then use Hera to encrypt and obfuscate that. But what we're doing here is just simply leveraging the Docker hub, and we're going to go ahead and download some open source images. So we're ensuring that it's there, we're downloading that image, and what ports we're going to go ahead and do port forwarding for.
Yeah. And like Trish just mentioned, if you're using Hera, then you're definitely able to still leverage the modules as they are and be able to use whatever lookups you have, depending on your specific environment. If you've got different Hera YAML files for your production environment as opposed to your dev, which would make sense too, or even other parameters like your data centers in various locations, et cetera, you can still leverage all of those capabilities with the Docker modules.
I also want to point out that we are using, oh, thank you, Grace. We are using the Puppet environment from Grace's talk last year of Puppet up and running in 45 minutes. So if you do not already have a Puppet environment to use and play around with, you can go out, we'll make these available, but you can go out and download those from GitHub, and then you'll have a Vagrant file to go ahead and then we'll automatically build a Puppet enterprise as well as a node, and then you can go ahead and leverage our modules today where you can go ahead and start playing around with Docker.
And it's literally the smallest environment ever. It's a Windows VM and a Linux VM, a CentOS 7, and a master. So it's just 3 nodes, and it should, if you use the README, be very intuitive to use and get started with. So I encourage folks to check that out.
All right, so let's get into a demo. And where am I? All right. And so, Grace, you can help me through some of this, right?
That's right. Tell me that's why I'm here.
All right, so what are we looking at?
Awesome. So we're looking at a Puppet manifest right here. So what we mentioned earlier, what we're going to be using that Docker image build to leverage is this manifest that's doing a few things. You see at the top, we have that dummy service. So that's also one of the modules coming from the Forge, letting us know that our provider is dummy. And then also we're just spinning up a small little Nginx server, and it's declaring that class Nginx. So for those of you who are familiar with Puppet, none of this should look too crazy. And for those of you who've not seen a Puppet manifest before, it still shouldn't look too crazy. We really pride ourselves on having a declarative language that you can look at and be able to understand what's happening. And you see here that we're saying that we need a specific file resource to be present. It's that index.html, giving it that var www.html directory path so it knows where to even find it. And then we're saying that this is the content that it should have. And we actually have the content here. It's a JPEG, so it's going to be an image and what the positioning should be. So it's just some standard HTML right there. And that's another really cool thing about using that file resource within Puppet. We can actually even right there in that line specify what that content should be, and then also what the exec is. So it's executing a specific thing, which is disabling the Nginx daemon, and it's showing us what the command is for that, an unless issue, so in case it shouldn't do that, and then what the path should be. So this little bitty block of code, I would say maybe this is 15 lines of Puppet code, is going to spin up this Nginx web server for us and get us going. Awesome. And then we've got this metadata.yaml file, and you're going to see some things look a little bit familiar even from that Docker file, right? We're telling it what the command is, nginx. We're exposing a specific port, which is going to be 80, and then we're giving it an image name. We're saying what it should have, which is tchung02 /puppet nginx. So we have that metadata.yaml to help us be able to use the image build command to bring up this new image.
So with that information in place, all we have to do is then puppet docker build, right?
That's it.
And it's going to go ahead and build a Docker image out of that Puppet manifest of an nginx server. So with Docker now, so all the commands with Docker, and it's been recently restructured, but it's Docker, whatever you're trying to work with, so Docker image or Docker container or Docker swarm, that's going to be the next segment in that statement. So we're going to go ahead and do Docker image, and then ls, show me what images I have on this Docker engine. And as you can see, we ran this a little bit earlier to make sure we had it built and didn't have to use the Wi-Fi. But we have that Puppet nginx, the latest build was about an hour ago. And we can go ahead and start it up. So Docker container run -d, so a detach mode, -p, and I'm going to go ahead and port forward, and then my container name. And then it gives me a container ID. If I do Docker container ps, that's going to show me that this container is running, and you can see even in the ports that 8043 is going to be available. In our environment, we have some hard-coded IPs. So I'm just going to go ahead to this IP and port, and you'll see that now we have that simple web page loaded with the Docker and Puppet image. Adorable. So now back to Docker, we can just go ahead, Docker container stop, and just a couple of the first couple of characters for the container ID, and it will go ahead and stop it. And it's no longer running, and if we go back over to the browser and do a quick refresh, you'll see that it's gone. So that's how easy it is to go ahead and leverage existing containers and start and stop them.
Awesome.
So
now we're going to do a similar workflow using the UI. So how many people here are using Puppet Enterprise already? Oh, nice. Okay, nice. So we're going to have a very similar workflow to what Tricia did, but instead of doing it from the command line, we're going to leverage the GUI, because why not? So we're going to get started in a traditional way in which we simply go ahead and create a node group that we would like to manage. And so we're going to call this Docker. And we could add a description, and we'll just put Docker demo. And we're going to make sure that it belongs to all of our nodes as our parent group, but you can specify which one it needs to be a part of. Maybe you've got some test nodes which are a part of your Docker environment that you need for this to be a part of. You can have that be their parent. What's really great about nestling things in that parent-child relationship is if you don't apply any specific classifications to this node group, it's going to inherit from its parent, which can be helpful sometimes if you have larger environments and you're doing a lot of complex things to know that that inheritance is at play. And then the environment is production, because that's the only environment that we currently have. So we're going to go ahead and add that. We see it pops right up. And then we're going to go ahead and go into that node group, and we're going to select the node we want. So I'm just using that Linux VM. So we're going to pin that node. We're going to commit that change, and we're going to apply a class. And we're going to refresh this because it says it hasn't been refreshed in 8 hours. But the class that we're going to apply is going to be that nginx class. And so if we just look at, I think it's start nginx container, add that class. It's got no it's not a parameterized class, so there's no values to change or pass through here. So we're going to simply commit that change as well. And now we're going to run Puppet on that node. So we're going to go to matching nodes, Linux VM, And we're going to run Puppet. And I mentioned no op earlier. You have the option of using the no op flag right here in the GUI as well. But we want to make sure this runs. Because fun fact, when you're working with containers and you select no op, nothing actually happens. When you go to that IP to see if, we trial and error, we're like, why is nothing happening? And it's not happening because it's running in that non-operational mode. So it's just a simulated change. So there's no container to go and look at. So that's something to be mindful of. And you see here that we've got an intentional change, which is precisely what we want to see because I did that on purpose and I used a Puppet prescribed workflow. So now let's go and look if that is working. And is this the right?
84.
88. Oh, what am I doing? It's 8043, correct?
Yes. So this is our Linux VM that we have running.
Awesome. And so we have that same image of the Puppet logo and then the Docker logo side by side, which is what we wanted to see.
So what we have then is on our Linux VM, Docker is now installed. I can do a Docker image ls and see which images have been downloaded and are available to that host. And if I do a Docker container ps, now you see that that Puppet Nginx is running on this Linux host that was managed by Puppet.
And it was created a minute ago. So it's giving you that rapid capability of spinning up a really fast container. So if we go back to our UI, we can now also do a few other things, and we can look at that reporting that I mentioned earlier. So being able to see, of course, the log files, right? So you see the log here, you know what's happening, where it's happening, the source, the code, the path to that source, and what line of code is affecting the change that's being made. That's always really cool. And then being able to also see it from this event view where you can see what intentional changes occurred and where they occurred. So we see here that we have that Docker service working, and then we also have that image Nginx up and running. So being able to still, once again, have that reporting capability you have now for any of your other resources with your containers as well. And then, of course, we want to maybe stop that container. So we're going to go back into that same class, and we're going to simply remove this class and apply the stop Nginx. And we're going to commit those two changes. We're going to run Puppet again. And so we're going to run it here and wait for a few seconds until we'll be notified when that job is complete. And then we're going to be able to refresh this, and it should be unreachable. So we're able to do the same thing that Tricia was just doing from the command line right here in our GUI. And when we check this out, it's gone. Yay!
So a couple other things to note is that the way Puppet is doing this and managing the Docker run is it's actually using your system init. So if I did like sysctl, you'll actually see a service created to start and stop that Docker container. And one thing we did not show you was just how simple that manifest actually is to be able to start and stop containers. So and you saw a snippet of it earlier, but it's really just saying, hey, here's the image, as well as making sure that it's there if it isn't already, and that port mapping.
Yeah.
Right? And the same thing would be for stopping a container. All it's just saying is making sure that it's absent, and it's going to go ahead and stop it.
Yeah. Excellent. And so with what time we've got left, we'll show you another quick example because it's a little more interactive. And it has to do with cats.
When I teach the Docker 101 class, we actually build a thing, thank you, Mike Coleman, but we build a Python app that you saw that Docker file of called CatWeb, and it just goes out and does random cat images. So, who doesn't love cats?
The internet does.
They sure do.
And so in order to even do this Puppet run, we're going to leverage something called Puppet jobs. So in the keynote earlier, you probably have heard about discovery and all these fun and great features that are released in this latest version of Puppet. This is one version behind, so this is actually 2017.2, not .3. I will update that in the Vagrant file so that you all have all of the functionality that was released. But if we go to jobs, we're able to then run a job. So a Puppet job is simply giving you a way in which to run Puppet across your environment without doing what I just did of having to go to my node list, specifying the node I want, and then clicking run Puppet right there in that job, in the view for that node. It lets me be a little bit more large scale in the way in which I'm executing Puppet. So we're just gonna say example. And once again, you can pick the same sort of parameters that you can for traditional runs, whereas, do you want it to run in production or another environment if you've got it, and then do you want it to run in no-op mode? And then you're also able to run across your inventory by specifying some information about it. You can pick it from a standard node list, or you can actually run PQL queries, and that's Puppet query language. How many folks are using PQL in their environments right now? Kind of, sort of. Well, I am a big fan of PQL. I think it's really great for being able to, I call it facts on steroids. I don't know if that's like a proper term, but what it really lets you do is it lets you leverage your facts, and your facts are your inventory items about your system, and also be able to bundle that together with other key pieces of information you need, right? So some examples of that are, do you have a specific resource like a package, and then the name of the package, and then the version? So you could even query across your environment, what nodes do I have that are running this package and this version of this package in order to, if you need to update a package, change a package, install one, etc. So the queries can get layered and can let you start to really filter through your nodes. And it's really helpful in large environments or complex environments where you have a lot of key facts that help you manage your systems. So I definitely encourage folks to get started with Puppet query language and do some exciting, queries there. I'm going to use the most basic, bless you, the most basic query humanly possible, where I'm just calling for all my nodes, because, well, there's only so many of them. And so we're going to submit that query, and as soon as I did, you see the 2 nodes in my environment popped up, and we're going to run that job. And we can start to see some information about that job. There's job details up here telling you what it's running, and also a progress bar to see at what percentage we are in that job. So when it's finished, it'll complete and tell us, and then we can also look at reporting as we did earlier.
Ooh, one's done.
50% done, there he is. And what's really great about this is you can also rerun past jobs. So if you go back to that jobs list and there's a job that you really enjoyed running, you can, or that executed perfectly and that you want to be able to execute again, you can do that by simply selecting the job. And so that, I think, really helps to cut down on time in our workflow, especially if there's past, jobs or past configurations that were pristine in our environment, being able to roll back that way.
So now change that to 50-50?
50-50, all right. How fitting.
So that's our Linux VM. And then if we also go to the master, which is another VM, and change that to 50-50.
Oh, I didn't add the, see, perfect example. If we go to our classifications, we'll see that I did not add the master node to this class. So that's why that's not working. But that will be easily fixed. We'll pin that node. We'll commit that change. And we'll just run real quick on the master. And that should come up as well. But that's a great example of a lot of times the question that we've been asked, and that we've been asking ourselves even, is why would I want to use Puppet with Docker? And this is definitely an introductory example, right? This is just to kind of get everyone's head wrapped around what does Puppet do, what does Docker do, how can they do them together? But that's a great example. If you need to spin up a container on another node, and you need it to look just like the node you currently have a container spun up in, you can do that with Puppet. You don't have to then figure out, oh my God, how am I gonna do this? Where's this container gonna go? Blah, blah, blah. You can, if you have a Puppetized environment, environment, you can simply specify, I need this node to look just like this node. And in this case, it means spinning up the same container to see if it's responsive or different in any way, especially if you're running across different OSs or even different flavors of Unix or different versions like CentOS 6 as opposed to CentOS 7. And you need to make sure that compatibility is there across, you know, a heterogeneous environment. So now when we go back and we refresh this, oh, that's not a cat. I mean, it might be a different kind of cat, but that's not the one that we were expecting. Let's refresh it again, and so we've got a kitten this time. But so we can see that also happens in the world of containers. Bloomberg just
and live demos.
Up. Yeah, so what happens when you're live? So we have the same container running on 2 separate nodes, and so that's awesome. And when it's time to bring down those containers, we can do the same thing that we did earlier with the Nginx example, and we can simply just use a different class. So we're going to remove this class, and we're going to add stop cat web, and then we're going to run Puppet again, and I'm going to go to my jobs tab again, and I'm actually going to run this example job because what it did is just ran across my environment, which is what I want to be able to do. So why is it not letting me rerun this job? Oh, I lied. Maybe I'll just create a new job.
Oh, it's for stop.
Yeah. So then I'll do all nodes again. I'll submit, and I'll run. And then we should be able to see those containers stopped. Excellent. I think
that's really it, folks.
We do have one more last slide.
Oops, if I can get to it.
One more last. Awesome. And so that's our honorable mentions. We really want to make sure that we give credit to the folks who helped us get here. And so we want to first shout out 2 other talks that are happening that are about containers. So Scott Colton is also a Docker captain based in Australia. He's also a Puppet employee, and he's doing Zero to Kubernetes tomorrow at 3:15. It's one of the later sessions. And there is a blog post that we also leveraged in getting this environment set up that we encourage you to read. And then Gert Drapers, who's the VP of Engineering, Cloud Containers Discovery and Insights at Puppet, is going to be doing a State of the Union on containers at Puppet tomorrow at 11:45. So we definitely encourage everyone to check that out. They'll be doing some more advanced Docker stuff, Puppet Docker integration stuff in the Zero to Kubernetes. And then Gert will be really giving us a great lay of the land and the idea of where we're going as a product and how we're going to really leverage ourselves in a containerized space.
Excited to watch them. All right. And that's it. Thank you.
Yeah.
We'll do our best.
All right.
Just step on up.
I'm trying to understand the advantages of using containers. Like Puppet already gives you the ability to install Apache or Nginx, so on and so forth. But what's the advantage of doing that via a container? I mean, one I can think of is like, well, I could deploy 100 instances all with different port numbers, for example, using port forwarding. But maybe you can discuss that. And as a side note, how is the performance when you put an app into a container like this as opposed to just installing it natively on a VM?
Well, it gives you that flexibility to be able to leverage the resources. Like if you install Nginx on a bare metal system, then that's all it's doing, right? If you install, say, a database to run alongside it, now they're coexisting. Whereas in a container world, you can isolate them from each other or open up communications between them, but then control the environments that they run in, right? So it gives you that flexibility as well as I mean, there are some similarities and overlap, but it does give you the control of building everything and then shipping it anywhere you need it to run, and it's going to start up really just quickly because it's already installed. Whereas Puppet will, as you saw in that manifest, it's going to go ahead and install those things for you, whereas the image is already built with everything you need.
So like maybe from a testing perspective, it's a great tool.
Yeah.
Something else all in one machine?
Sure.
That's what I was going to say. I think testing is also a place where containers really shine. Sometimes you don't want to bring up an entire new VM to then test on or have a pool of VMs that you test on, but being able to spin up an ephemeral environment that's container-based lets you do that rapidly and bring them down rapidly without having to expend as much resources and even creating that test environment to do so.
I think about it also in the sense that now if you want to scale, it's going to be a lot faster to scale as well, right? Because it's just booting that application and it's already all the dependencies and what it needs is there in that image, right? It also, a lot of times when we first started learning about Docker, it was around building microservices. But then how do we address that for the monolith applications or everything that's been legacy? And I've spoken with quite a few customers over the years that are actually now using Docker containers to move their legacy applications so then they can move them wherever they need instead of having to manage them on that existing infrastructure and afraid to move it anywhere.
Great question, thank you.
How does this compare to Kubernetes or Swarm, and how does that integrate with this?
I think that's going to come up more with a conversation with Scott, that it's not necessarily a comparison, it's a starting point of what we've discussed, and then getting more advanced with leveraging containers using Kubernetes and Puppet.
And I think Scott's talk's also going to focus on how that lends itself to large-scale orchestration and being able to scale and deploy apps and do a lot more of the intricate stuff that a lot of folks need to do.
Cool. Any other questions? Well, thank you for your time.
Awesome. Thank you.